All right, this video is on multiplying fractions. All right. The area models below represent two multiplication problems. Use your understanding of example A to complete examples B and C. So we have 2/5. So we take this square and we divide it into 5 sections. And then we color 2 of them. Okay. And then it's times 3/4. So we take it this way and divide it into 4. So here's 1, 2, 3, 4. And here's 1, 2, 3, 4, and 5. And when you color those, you've got an array of 20. And then what's overlapping there is 1, 2, 3, 4, 5, 6, which is 6 over 20. And that reduces to 3/10. Here we have 2/3. So we've got 1, 2, and 3. And 2/3 of that is shaded. All right. Here we've got 1, 2, 3, 4, and 5. And then we're shading 3 rows of the 5. And what overlaps, we've got 3 and 5. So the bottom is going to be 15. And how many of those 15 are shaded? 2, 3, 4, 5, 6 is 6 over 15. And that can reduce to 2/5. Each side is divided by 3. All right, here we've got 5/6. So we've got 1, 2, 3, 4, 5, 6. And I'm going to take my highlighter and I'm going to color or shade 5 of those 6. All right, and then we've got it divided by 1/4. I'm going to take a different color and shade the 1/4. Now, how many pieces altogether do we have? 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4 is 24. And how many of those are shaded? 1, 2, 3, 4, 5. So the answer there is 5/24. All right. In order to multiply fractions and mixed numbers, each number must be written as a proper or improper fraction. Mixed numbers must be converted to improper fractions, and whole numbers must be written over 1. Okay, so the steps for multiplying fractions are: change each mixed number to an improper fraction, multiply the numerators, multiply the denominators, and simplify. So down here in example 1, we've got 2/3 times 4/5. So we multiply the 2 times the 4 and we get 8. And we multiply the 3 and the 5 and we get 15. So that answers 8/15. Over here we have 6 and 2. So 6 times 2 is 12. 7 times 7 is 49. And that's as low as that'll go. So 12/49. Common factors. Common factors between the fractions can be simplified. example, 2 times 3 over, or times 3 times 4. And what they mean, simplified before you're, or after you're multiplying, if we look at this, and we look at our cross multiplications here, what number goes in 2 and 4? And that's 2, right? So 2 divided by 2 is 1, and 4 divided by 2 is 2. And then 3 and 3, 3 divided by 3 is 1, and 3 divided by 3 is 1. When you multiply that, 1 times 1 is 1, and 1 times 2 is 2. So that's common factors can make that smaller for you guys. And then after here, 2 times 3 is 6, 4 times 3 is 12, and when you simplify that, you get 1/2. Either which way you want to do it is fine, and this can't be done all the time. Okay? So practice multiplying the mixed numbers and mixed numbers below, and be sure to simplify your answer. All right, 4 times 3 is 12, and 9 times 4 is 36. What number goes into both of those, which is 12? So if we do 12 divided by 12, we get 1. 36 divided by 12, we get 3. So your simplified answer is 1/3. All right, here's 2 1/2 times 3 3/5. And remember our steps, you have to change the mixed numbers to improper fractions. So you would do 2 times 2 plus 1. So 2 times 2 is 4, plus 1 is 5. So you get 5 over 2 times 3 times 5 plus 3. So 5 times 3 is 15, plus 3 is 18 over 5. And we can simplify to make that more manageable. 5 goes into 5 one time. 5 goes into 5 one time. 2 goes into 2 one time. And 2 goes into 18 9 times. So we multiply 1 times 9, we get 9. And 1 times 1 is 1. And when you simplify that, you get just 9. A recipe requires 2 1/2 cups of sugar. If Miss Marine is going to make 1/2 of the recipe, then how much sugar does she need? Okay, so we have 2 1/2 times 1/2. So 2 times 2 is 4, plus 1 is 5. So we've got 5/2 times 1/2. 5 times 1 is 5. 2 times 2 is 4. How many 4s are in 5? And that is 1 with 1 left over. So the answer is 1 1/4. A rectangle has a height of 1 1/4 inch and a base of 5/6 inches. What is the area of the rectangle? So we know that the formula for area of a rectangle is base times height. So we have 1 1/4 times 5/6. We have to make this an improper fraction. 4 times 1 is 4, plus 1 is 5. That's 5/4 times 5/6. 5 times 5 is 25. 4 times 6 is 24. How many 24s are in 25? That is 1 with 1 left over in the denominator of 24. And that's area, so that's going to be inches squared. Okay. 4 students were each given a card with a fraction on it. They were then asked to pair up with another student and multiply the fractions. So when Omar and Andre multiplied their fraction cards, they got a product greater than 4. So Omar is 1 3/4. You got 1 3/4 times Andre's card, which is 1 5, 6. Let's make them improper fractions. 4 times 1 is 4 plus 3 is 7. So we have 7 fourths times 6 times 1 is 6 plus 5 is 11 over 6. 7 times 11 is 77, and 4 times 6 is 24. How many 24s are in 77? And that answer is 3. That would give me 72, so that means there's 5 left over, and that's 3 and 5 24s. And it said that they would get a product greater than 4. So is that true or false? That answer is false, because that's not greater than 4. All right. If Ira multiplies her fraction card by any of the other cards, the product will always be less than 1. So ours is 1/5. So if you multiply Ira's card by any of the other ones, it's going to be 1/5 less than 5 would be less than 1. 1/5 of any number, let me change that. Less than 5 will be less than 1. So this one is true. When Ellie and Omar multiplied their fraction cards, so we've got Ellie, which is 2 2/7, times Omar, which is 1 3/4. Their solution was between 2 and 3. So let's see. 7 times 2 is 14, plus 2 more is 16 over 7, times 4 times 1 is 4, plus 3 is 7, which is 7 fourths. I can see here that we can simplify this. 7 divided by 7 is 1. 7 divided by 7 is 1. 4 divided by 4 is 1. And 16 divided by 4 is 4. 4 times 1 is 4. 1 times 1 is 1. That would be 4. And it says the solution was between 2 and 3. So that is false.